Hi everyone and welcome to our presentation for assignment2. Our project is called Cross-Platform Analysis of Australian Public Opinion on Elections, Wars and Tariffs. In this project, we built a crowd-based system that collected and analyzes real-time social media data to explore how people feel about key public issues. Okay, next slide. There are our team members' information. Okay, here a quick overview of what we'll be covering. We'll start with the system architecture and explain how the different parts of our pipelines work together. Then we'll show you some of the results we get from analyzing over 1.2 million comments. After that, we will also go through some of the key challenges we run into and how we solve them. And then we will demonstrate our system's dynamic scalability. And finally, we'll do some actual demonstration.
In this section, we'll look at the overall system design. Figure 1 shows the system architecture diagram. Our system follows a microservices design and is deployed on Kubernetes. All the backend logic is split into small efficient functions, each doing one specific job, like data crawling, pre-processing, sentiment analysis, or querying. These functions all talk to Elasticsearch, which stores and manages the data. Because everything is separated, the system is highly modular and easy to maintain. It's also fault tolerant. If one function fails, it doesn't crash the whole system. We can also scale it easily, either by running more replicas or adding new functions as we bring in new data sources or topics. Figure 2 shows the end-to-end query flow. Here is how a typical query works. The front end, which is a Jupyter notebook, sends a HTTP request to one of our phishing functions. That function builds a DSL query to Elasticsearch, fetches the result, and sends it back. This setup keeps the front end completely separate from the back-end logic, so the front end doesn't need to understand the database schema or any query syntax, which makes development a lot easier and much more flexible. We can change the backend anytime without breaking the front end. Now let's talk about how we store and organize the data. We use 3 Elasticsearch indices, each handling a different stage in data pipeline. First, we have social comments, which store raw data from Reddit, Mastodon, and Blue Sky. Next is processed comments, which holds data after sentiment analysis and topic classification. And finally, there is comment result, which contains aggregated sentiment statistics grouped by date, topic, and category. This layered design makes it easier for us to process data step by step, and to build up or update each part of the pipeline separately. To prevent duplicate data during batch processing, we generate structured document IDs, so each entry is unique, and repeated imports won't create duplicates.
Let's start with a quick look at the data we are working with. We collected around 1.2 million comments from 3 social media platforms: Reddit, Mastodon, and Blue Sky. These platforms each have different user bases and discussion styles, so combining them gives us a more complete picture of how people are talking about with the big issue. In this figure shows where all the raw data comes from. Broken down by platform, it gives us a good sense of the structure of dataset. The last figure is the first step of the visualization. A line chart shows how sentiment scores change over time. For example, in this figure, we look at the election topic and break it down by political party. Each line represents how emotional tone shifts day by day. You can hover over any point you see the sentiment on a specific date and compare how different parties are being talked about. It's great for spotting long-term opinion trends or short-term emotional spikes after the major events. Uh, this chart focuses on how active people are in this discussion, shows the number of comments posted each day on the election topic, again broken down by political party. This helps us say when conversation really picked up, maybe in response to new stories, speeches, or campaign events. It also let us compare how much attention each party is getting on social media over time. Now, this chart is broken down the number of positive, neutral, and negative comments each day, which gives us a snapshot of how people are feeling. Not just whether they are talking about, but what kind of emotion they are expressing. Then we have the word cloud in this figure, which highlights the top keywords within each topic. The bigger the word, the more it's being mentioned. All the visuals are updated daily and can be filtered by category, like political affiliation. Comments that don't fit into a clear category are grouped under them to keep things consistent. Although this tool helps us to understand how public opinion around the major political and social issue in Australia is evolving from the angle of time, emotion, and political focus.
Okay, now we'd like to move on to the third part of our presentation, which focuses on the challenges we encountered during development and how we address them. There are three main issues that we made in our work. The first one is phishing. When we first set up the backends, phishing gave us quite a few challenges. Functions often failed without clear error messages, sometimes due to cold starts, missing dependencies, or Kubernetes issues. It made debugging slow and frustrating. To fix this, we made three key changes. First, we set min scale equal to 1 for key functions to avoid cold starts. Second, we used zip packaging with a build point sh script to ensure all dependencies were installed properly. Third, we test everything locally and added details logging to help with the debugging in deployment. With these steps, all 6 core functions was deployed successfully, and data starts flowing into Elasticsearch as expected. Okay, the next issue we made in our work is data crawling. At first, we are only collecting Reddit comments about the Australian election. That gave us around 60,000 comments. Not bad, but far from enough for meaningful analysis. We soon realized that focusing on a single topic and platform was too limited. So we expanded to include 2 more topics, words and tariffs. However, general terms like word and tariff still didn't return relevant resource. To solve this, we created a topic point JSON file with 156 specific keywords, organizing by topic and platform, such as a referendum or trade agreement. These keywords are then used by our crawler functions to automatically search for and collect all matching comments across platforms. We also add unique IDs to each comments. This helps prevent duplicated during repeated crawls. With these changes, both the volume and quality of our data improves significantly. There are another issues that made in our working process. As the system grows, we notice a lot of repeated code, especially around Elasticsearch. Functions like data crawlers and sentiment processors were all doing the same thing, collecting to ES, format data, write documents. It makes the code harder to manage and more error prone. So we created a shared utility model called elastic write util.py. It handled all the common Elasticsearch logic, like setting up the connection and generating IDs, so each function can focus on its core task. This made our codebase much clearer and more consistent, and is now easier to maintain and extend.
And then, one of the main goals when we built this system was to make sure it could scale dynamically. And we've done that in 3 ways: by topic, by platform, and by functionality. First, topic scalability. We use a Zhenxin config file called topics.json that lists all the keywords and subcategories we care about. When we first started, we were only collecting data on elections, but pretty quickly we saw the need to broaden our scope. So we expanded to cover 3 big topics: elections, wars, and tariffs. In total, we added 156 keywords, neatly organized by platform and subtopic. The beauty of this setup is that we don't need to touch the backend code to add new topics. We just update the config file and redeploy the curl. That saves us a lot of time and makes it super easier to adapt the system as our needs change. Second, platform scalability. All our interactions with Elasticsearch, reading and writing, are handled through a shared model called elasticwriteutil.python. What this means is, if we want to support a new platform like Twitter, Facebook, or even live WebSocket feeds, we just need to write a curl that outputs data in the format we expected. From there, it can plug straight into our existing pipeline by using that utility model. For example, we start with Reddit. Later on, we added Mastodon and Blue Sky, and that only took minimal code changes thanks to these shared abstractions. Third, functionality scalability. Our system is built from independent fission functions, all deployed on Kubernetes. Each function does one specific thing, like querying, processing, or querying data. This modular design means we can add new features without messing with what's already working. So, if we want to upgrade our sentiment analysis, say switch from a rule-based weather model to a deep learning transformer, we don't have to rebuild the pipeline. We just deploy a new function and reroute the data. The same goes for adding other analysis tools like keyword extraction, topic modeling, or bot detection. Each can be added as its own function, running separately. So overall, these modular and serverless architectures give us a ton of flexibility. Whether we need to bring in more data sources, run more advanced analysis, or pivot to new research topics, the system is all ready to grow with us.
Now I want to demonstrate our front-end system based on Jupyter Notebook to you. Before we run, make sure that you configure the cluster correctly and configure the port forwarding to our fission. And you can type which is the earliest day to pull data from, and run all. The scripts will collect data from the back end. And you can see the figure is here. You can use these 3 drop-down lists to select topic, category, and which figure you want to look. The first figure is total sentiment score over time. You can hover the mouse to select an exact day to get more detailed information, and drag to zoom in some duration to get your own compare. And also you can click here to hide some category or show them. In this chart, the purple line means that the Liberal Party and the green line means that the Labour Party. And you can see that the purple line is always higher than the green line. But at the end, the Labour Party won the selection. The result is really different from the reality world. Let's move to the second figure. The second figure is total commands over time, and also you can zoom in. We can see that the Liberal Party has more commands than the Labour Party. And about the third figure, we can see how many positive, neutral, or negative commands by different party. To see the data clear, use this drop-down list to filter. Just show the Labour Party. We can see that most of the commands are positive, just a few negative commands. The same results is shown by the Liberal Party. To explore more results, you can select the topic, like the tariffs. In the tariffs topic, most of the commands are negative. And in the topic words, similar results.
Okay, the last part, now I'm going to walk you through the backend part of our system. First, let me introduce the three electric search index we used. Okay, let's use Kibana to show the three index. The first one is social commons, and the second one is processed commons. This is the field in this index. And the last one is commons resort. Okay, and this one is to store the raw data. This one is to store the sentiment analysis resource. And the last index is to store the aggregate resource. Okay, next, here are the functions we've deployed on fissions. Let's use the fission function list. Okay, there is all the fission functions in our Kibanas. We have data crawlers for Reddit, Mastodon, and Blue Sky. This one is a Reddit crawler, and this one is a Mastodon crawler, and this one is a Blue Sky crawler. And these functions collect posts and comments from each platform and write the data into the first indexed social commons. Okay, the next one is process clean. This function here performs sentiment analysis. It pulls unprocessed data from the first index, calculates sentiment scores, and classified topics, then stores the results in the second indexed processed commons. Then we have an aggregation function, this one. It reads from the second index and summarizes the data by topic and date. So each topic gets 1 record per day and save the result in the third indexed commons resource. Finally, this function served as an API interface. And finally, here is a quick overview in Kibana of the data we collect by May 21st. Okay, the first index, this is the first index, contains around 1.47 million row comments. This is the second index, and it contains 1.3 million comments. Okay, the last one is the results index. It contains 20,000 aggregated records. This is all of our backend. For more details, please refer to our reports. Thank you. This is all of the presentation.